5 domain is all reals because nothing makes the denominator 0. It has no holes. For x-intercepts, you need to, the numerator actually has a 0, and the thing about this one is you couldn't even, there's no way you could find it by hand. You needed a graphing calculator for that. So let me give it to you right now. So this is not something I would ask on a test or a quiz. This one assumes that you have a graphing calculator and that you're using it to solve, and it turns out to be negative 2.594. And again, it's just a rounded number. It's an approximation because it's an irrational number. The y-intercept, though, you could find it by covering up all the x's, so you're going to cover up all these, and you're left with 4 over 1. So that's going to be 0, 4. It has no vertical asymptotes, okay, because the domain is all reals, and it does have a slant asymptote because it's a top-heavy problem. So I'm going to use long division because we can't use synthetic for this when the divisor is 2x squared plus 1 cubed plus 2x squared. Remember the placeholder 0x plus 4. So 2x squared goes, what do you have to multiply 2x squared by to get x to the third? You have to multiply the 2 by a half, so 1/2 x. And then you multiply, you get x cubed plus 1/2 x. Let me erase this, it doesn't go here. And then from there, subtract. So this cancels and you have 2x squared minus 1/2 x. That's 1/2 right there. Bring down the 4. And so what do you have to multiply the 2x squared plus to get 2x squared? Well, that's 1. And what follows is the remainder, and we don't care about it. So this is your slant asymptote, y equals 1/2 x plus 1. Okay? Okay, so this one has no vertical asymptotes, but it does have a slant. Y equals 1/2 x plus 1, so start there. Up 1 over 2. 1 over 2. Oops, doesn't go there, sorry. So around here. Or we can go down 1, left 2, down 1, left 2, down 1, left 2. Okay, we connect it. Like that. Let me erase this little extra mark there. Okay, and then we have a x-intercept again. This x-intercept, you couldn't have gotten it any other way but by using a graphing calculator. Okay, you just plug this into the calculator and ask it to solve or find the zeros, and it gives it to you. Okay, so that's the only way. So negative 2.54, so about negative 2.6, so approximately right here. And then the y-intercept 0.4 right here. Okay, so remember, the horizontal and slant asymptotes give you the end behavior. Okay, so this is going to be a weird curve. It's going to go like this, go up a little bit towards that, towards 0.4, then it's going to curve back down at some point and go back towards that asymptote. Now we could plug in f of 1 just to see how, if I was close enough right there, or if I have to make it a steeper curve, we'll see. F of 1 would be 1 cubed is 1, 2 times 1 squared is 2, plus 4. And then 2 times 1 squared is 2 plus 1 is 3. So 2 plus 1 is 3. So in the numerator I have 7 over 3. So that's going to give me 2 1/3, right? So 2 1/3, yeah, I should have I should have made it a little bit steeper, so let me go ahead and fix that right now. So 2 1/3 is about here. So it goes something like this. And it gets closer and closer to the asymptote. Okay. On the left side, the same thing. I could probably plug in a -1, see what happens. F of -1. So -1 cubed is -1. -1 squared is +1, so +2 plus 4. In the denominator, I still get 2 plus 1. So 6 minus 1 is 5 over 3. So that's 1 2/3. So on the left side, oh, that was pretty close. 1 2/3, -1, about right here. Okay, so kind of like that. And that's your graph.